in this problem. Consider the circuit shown below. Find I1, I2, and I3 when the switch is first closed. So the switch is closed and we want to find I1, I2, and I3. After the currents have reached steady state values and at the instant the switch is reopened after a long time. Alright, so part A, we're solving for this problem at t equal to 0. Now we will call these currents I1, R1, I3, R2, I2, L. Alright, in an inductor, the current varies as with time as I2 max 1 minus e to the power of minus t by tau, whatever the time constant is. And so I2 at 0 seconds would be, this would be t equal to 0, so this would be 1, and I2 would be 0 at 0 seconds. Okay, so that would imply I1 equal to I3 at t equal to 0. And so if you go around this loop using Kirchhoff's rule, what we get is, so using Kirchhoff's rules, using E minus I1 R1 minus I3 R2 equal to 0, but since I1 is equal to I3, but E equal to I1 R1 plus R2. Again, let's add the sheet. So I1 equal to E over R1 plus R2. Okay, so at t equal to 0, I1 equal to I3 equal to E over R1 plus R2, and I2 is equal to 0. So those are the three currents. Okay. Now part B says after the currents have reached steady state values. Okay, so part B, steady state value meaning t is equal to infinity. I2 as a function of time was I2 max 1 minus e to the power minus t tau, and at t equal to infinity, it's equal to I2 at infinity equal to I2 max. Okay, so we'll call that I2 max. So I2 is equal to I2 max. Okay, and also since the EMF since the EMF here is minus L di2 by dt, which is equal to 0. At t equal to infinity, di by dt is 0. So di2 by dt is 0. So this is 0. Since this is 0, I3 is 0. There's no voltage across here, and so this arm doesn't see any voltage, and that implies so I1, I2, I3, and this implies I3 is 0. Okay, so that means and that implies I1 equal to I2. So at t equal to infinity, I1 okay, so I3 is 0, I1 equal to I2, and E equal to I1R, applying Kirchhoff's rule around this loop. Now the voltage across this is 0 because you have reached steady state values, so that's equal to that. So I1 equal to E over R1. So there are the three currents. Okay. And now when you open the switch again, now the circuit is, so this, now the circuit is, so for part C, there's R2L, and what happens is when you open the switch, you have, so the switch was over here, and when you open the switch, you remove this part of the circuit, so you're only left with this part of the circuit, and this part will drive a current like so. Okay. So the current will be like so, and the current in the circuit falls off exponentially, so I will be okay, so we'll call this current, we'll just call it I max times e to the power of minus t by tau. Okay, and I max really was the maximum current was this steady state value before you open the switch. So it was I2, which is E over R1. So IT is E over R1, and the time constant for this circuit, is L over R2, E to the power minus T over L, minus T over tau, where the time constant is L over R2. Okay, so so the three currents, so after the switch is open, after the switch is open, I1 is 0, I2 t equal to e over r1 e to the power of minus t L over r2, and I3 is minus I2. Okay. Since in the diagram the direction of I3 was in that direction, but after the switch is open, the current flows in that direction. Okay. Okay, that finishes that problem.